Okay guys, this is happening. Welcome back to another video of Dylan Hacks. So yeah, this is my face, real face. Today I'm gonna talking about something really serious and it's about battery replacement. So there it is, battery, two of these thing. So I bought the battery from AliExpress to replace my battery in my yoga book. So this is the original battery and well it's degraded over time because well anything degraded over time, and I bought one replacement and it came about 2 days ago and it looked like this. So it's exactly the same but with just sticker covering because maybe some kind of trademark or I don't know, but this meant to be a genuine battery. But when I put into my yoga book and I turned it up, put into Windows, it's revealed to just working properly. The CPU is go really hot. It cannot charge the battery too, and it's stuck at 100%. And just a couple seconds, it's forced shut down my computer. One possibly thing is the chip inside here, or something else about the battery, smart battery bus is went wrong and it cannot communicate with computer, so the result is the battery just virtually not exist, but it's actually there. It detect the voltage but it cannot talk to battery. So right now this battery, I don't know the charge cycle, how many times it's been charged, but this one is about 500 times plus because I've been using for years now, and the battery itself is actually manufactured in 2017, but this one they just remove that sticker like this one. So I'm gonna walk you through what happened here and what if sellers refuse to refund my order, what I'm gonna do next. So let's start with the battery testing. Let's go. Okay guys, I'm back. So I'm gonna test the battery. I'm gonna put individual one in the PC. I'm gonna turn it on. So first start off with my original battery. Just sit right there carefully, and I'm gonna connect the LPC connectors. These LED turn out right away. Gonna press a power button to turn this on, and you should see the LEDs light up here. Hello? Oops, it's not light up. Okay, let's try again. Oh, it's not power on. Okay, so I'm gonna plug. Okay, it's on. So we're gonna see something on the display. It's booting. Okay, I'm gonna input the password. I'm gonna show you, not gonna show you that. Okay, so it's took a while. Okay, we are in. So this is a normal PC will look like this. I mean the behavior of it. There will be nothing, although it reported the battery is 23%. It's in the battery saver mode right now, and I'm gonna charge my battery up. I'm gonna show you that it's actually charging. It's connected, LED lights up, charging. So this is the battery that came in when I first buy. It's built into this because yeah, it's the original battery, and the charge cycle of it is about, I'm gonna show you, I'm not sure, I'm turning this on right here, still open up, nope. So I'm gonna show you the battery cycle by using a command in Windows, powercfg/battery check, I believe, battery check or battery help, not sure. Gonna wait for a little bit, let this guy load up. So power cfg/battery check, oops, probably battery health. Wait, what's happened here? Battery check. What's happened here? Backslash invert parameter. Oh, it's a typo maybe. Man. B8. I have problem pronouncing battery. B8. It's a shame. Battery check. Battery health. Why it's not working? I'm gonna come back later if it works. Okay, I'm back. So it need to be powercfg/battery report. Yeah, and I got this file saved right here. Yes, just not sure. Control C will work. Yeah, it's working. Oopsie. Okay, let's see the battery report of my original battery, and here it is, the cycle count of this original battery. So I'm gonna close this one. We're gonna shut this down. No, I'm not gonna go to settings. Please, yeah. And then I'm gonna go with this battery. I'm gonna pause video. Okay, we don't need to pause the video. Pause. English. Okay, I'm gonna wait until this light is go off. I'm gonna take the battery out and put this in. Let's go out quickly, please. The CPU is really hot. Okay, it goes out now. So I can get this out, put it somewhere else, and take this so-called replacement battery in. I'm gonna connect a PC connector. Let's connect it very hard. It needs to be at the right place. Yep. If you can see, this LED is lighted up because the battery is already connected. Okay, so I'm gonna turn this on. Oh, it's turned on right away. Let's see what happened. Oh, is this turned off? Okay. shutting down right away. Okay, so I'm gonna wait until this guy is turned off, and CPU just not that heat up. Okay, so heat up a little bit. I'm gonna plug the charger in again and turn this guy on. Since this is not gonna power on, it's gonna keep shut down with this battery. The connection is really good. I probably thinking that is probably have a good contact, but something in here, the circuit is something is wrong. QC pass, just the sticker. Okay, I'm gonna connect the battery charger. The LED should light up. Yes, it's charging. Turn on. This LED should on. Yes, things should be on the display. After that, I might or might not logged into Windows, but if I can, it's gonna be just a brief moment before the window force shut down, because the CPU goes really hot, especially with this battery for some reason, I don't know why. And it's gonna read the battery status at 100%. And take a look closer here. It says it's charging. Yeah, just put the pin on. The pin is just fine. Maybe someone is not gonna hack my PC. This go really hot. Whoops. Oh, shut down right away. Yep, this is the problem with this battery. Yep, that is. The battery has a problem, and I tried to figure out why, but I cannot. And I have an idea. If I ask sellers and they refuse to refund the money, or they demand the battery to send back to them, I don't accept that, because sending battery back to them is gonna cost a whole lot more than the battery itself. It's not worth it. So if it went that way, it really went that way, I will do something. I will take this battery. As you can see, there's gonna be some circuit, and connect to the 2-cell battery inside this big blob of this battery. Okay, and I'm gonna take the circuit and then put to another one. Put into this one. Put it to this one. So basically, I swap the circuit so I can have a working circuit with a good cell probably. And I'm gonna try again, but right now this is nighttime, so seller is not responding. I'm gonna take a look at tomorrow, and I'm gonna continue this video tomorrow again. I'm gonna put some update to you guys with Movie Magic. I'm gonna edit that part into the same video, so let's see you guys tomorrow. Let's go. Okay, so before we move on to tomorrow, I'm gonna charge this battery overnight, and I'm gonna see it in tomorrow. Gonna see what happened. If it's still the same, I'm gonna still make this video. So let's this guy charge for a night. Okay guys, so this is next day, and it turns out that overnight I didn't actually put the laptop and charge it overnight. I just go back to the AliExpress listing and find out that it's actually this battery is for Yogabook running Android OS, but mine is running Windows 10 shipped with Windows 10, so this one is X91F. So the Android version is X91F or L. In case of LTE, you have L. So it's really confusing because like you have two products under the same name. Like you have a Yogabook, but one is running Android, different BIOS, different ACPI, and you have one running Windows, different BIOS, different ACPI. But you can actually using the same battery IC, and yes, two of these use the battery IC that I will explain later. Is that not work? I don't know why. Use the same chip. I will show you. So I literally took two batteries apart to remove the circuit. The one that look like this. It's not focused. It's just not focused. Well. So as you can see, there is a little chip right here. This is Texas Instruments. Let me. BQ27542-G1. I'm not sure you can see it, but this is something called battery fuel gauge integrated circuit. So normally when you have a battery, you just don't want to connect it directly to your circuit because sometimes your circuit really want 3.3 like 3 to 3.3 volts, but this battery can go up to about 4.3 volts that can fry some components. And they have a protection circuit like here, as you can see. Most of these just a protection circuit that like is only protect for overcurrent, undercurrent, or voltage under voltage. It's just a simple thing that all battery should have. But when it's come to something that more complex, like this battery that, as you can see, I literally took it apart. These are 2-cell battery. So what is 2-cell? Yeah, you can just use a regular battery protection circuit, but you make some device and you want to sell them and you want to make them really reliable. So introducing the FuseGate integrated circuit, FuseGate IC. This thing is really smart. It's a microcontroller that attached to the PCB that protect your battery right here. It's not PCB to protect your battery, but yeah, it's just a PCB. And it's do almost everything that, I don't say almost, it can do anything that this can do under voltage, over voltage. Just a simple stuff for the battery protection circuit. That is just like a level 0. But this chip is something that more advanced, that they have an I2C bus, they have the HDQ, I'm not sure, host device, something I'm not sure, is a battery protocol specifically for battery, like using in iPhone. So when you have FuseGate IC, you can do more. You can have a cycle count, you can monitor the current, voltage. It can even estimate the battery capacity. They have some kind of algorithm that proprietary to Texas Instrument. and they have a whole lot more feature. They even have some kind of flash, 64-byte flash like this one for this example of this one, so you can store like serial number or some information, useful information. And when you have two cells, you need to have a balance charger, which is this guy also manage balance charger as well. As you can see, they still have two MOSFET protection. But yeah, this is a piece of a PCB that I took off from the battery that I bought from AliExpress. It's a green one. Yeah, it's look like this. So I'm gonna explain the procedure a little bit. So first of all, I took a battery out, then I just try to get these black stickers out, not stickers, that it has a really strong, not that strong adhesive, and I use alcohol to just make them a little bit easier to pry off and expose the battery. And then I just pry off the battery connectors. It's really similar to this board. And then I just swap the circuit itself. I do the same thing with another battery, and it just look like this. And it turns out that it's actually working, but not right away, because when I first solder, the output is 0 volt. It's like it's an open drain maybe, and that is because of a protection circuit. Because when swapped the cell, sometimes the voltage is like the previous cell is, for this case the previous cell is about 3.2 volts and another one is 3.4. So let's do some kind of protection so it can make sure that the battery, when they get the battery out and it's put in again, that battery is actually working. So the thing that I do is I just put into my yoga book and let it charge for a little bit, and the battery just came back on. I can measure the voltage is around 3.4, 3.5, that's normal. Then I turn it on. At that time it has a battery about 83%, but that isn't the correct or the close to correct or close to the correct one, because I swapped the cell and the lifespan of the cell is different, and my cell is heavily used 542 charge cycles versus some battery, I don't know, maybe they may be just 100 or even less. So the thing that I do is I drain the battery from the 83% down to as close to 0 as possible. I just go just 2% and my window just decide to shut down. So yeah, when it go to really low, I just plug it in, charge it up to 100% again, and it just work fine. And it turns out that the design capacity, if I remember correctly, not gonna remember, take a look here. The design is 32.3 watt hour, and that battery is about 24 watt hour, which is still in a good ballpark compared to mine that is about 19, and sometimes it jumped down to 8, which is not reliable. So here we go. It's in the PC already. It might not look good, but I just hacked in a bit, and it turns out that my soldering job is not that good, and the alignment of the PCB is just a little bit off, so it's made a cable that I need to just tape it down really tight, because I worry about the clearance. So just pray it's gonna work. So I'm gonna go you through gonna show you some footage of me doing that things, and I'm gonna cut it to that part right now. Okay guys, so after that I have the battery working just fine. Next thing to do, I'm gonna put the keyboard back in. I forgot to tell you about that I opened this guy up and I put the thermal paste. It turns out that there actually some layer of the CPU inside the RF shield, which is between the CPU and RF shield, that has some kind of paste. I don't know, I cannot open it up because it just soldered the shield in because the clearance something, I don't know, the board is really thin, and they have some kind of graphite contact between two of the graphite. I'm not sure that is graphite or something. I just put the paste down. Is a Cooler Master E2 something, I don't know, and it's do the job really good, just fine. And I feel like it's actually better when like I play Minecraft. It's actually running around 82 or 83. It's right now it's just around 78, 79. It's okay, that is good. So I'm gonna talk about this guy a bit again. So so this IC is really interesting. Again, the name, I'm gonna read it because it's really long. BQ27542-G1. So I just searched up on Google. It turns out that there's actually a Linux driver for this guy, and I just thought again, yeah, if it doesn't have a Linux driver, this YogaBook cannot run Linux because they have a driver that requires battery to working properly. That's why it can show the battery percentage. So I'm gonna try to hack this guy by this interface. So they have 4-wire data clock, I'm not sure, maybe thermal sensor, and the HQI plus. HQI plus is really interesting, but it's not focused. It's not focused. Well, it's just a front-facing camera. It's not the HDQ interface is really similar to UART. They have people that actually build the circuit to convert UART into this HDQ. And by the way, this is a single pin, it's called bidirectional bus. So this is quite interesting thing to take a look at, because here I have the Lishi Pi Nano. It's currently running off a NAND flash. I finally make it working, and I'm gonna make video about that too in the future. I'm gonna get my Lenovo YogaBook back to the work again, and I also have to do something too. I used to replace a YogaBook keyboard before, and in the keyboard they have 3 separated parts. The top, at the top is a touch keyboard. It's not that touch keyboard, it's a touch screen. It's just basically just touch screen, and it's used Goodix chips, Goodix. I'm not gonna go in that detail because I'm not interested in it anymore. It's just a shattered glass. It's right there, shattered glass. But one thing that I really interesting is this thing. This is sheet of paper that really expensive, because on the back we have something right here. This is a board, and entire thing, this is a Wacom digitizer that I can use with a Wacom pen like this one. This is a Wacom EMR, and there's no datasheet out there on the internet. It's like maybe you need to do some NDA, like I want to make a product selling 1,000, 100,000 or millions of these to get the datasheet. But I managed to use the crappy multimeter that I have to probe the frequency of each pin, and at least I can make out some of the pin. Some of them seems to have a clock signal, data signal, but some of them is too fast, and my meter cannot measure that. It's really old multimeter. This one really old. So the goal is to use this as a Wacom digitizer, and I'm gonna connect up to this guy via I2C bus. I actually working on the driver. I'm not sure that it's gonna work, but right now I compiled it. It seems fine, and I have to find a patch to let it bind to device tree, because this guy is not ACPI based like x86 like Intel. So the device tree is a thing to bind two of these things together, and all the rest is to figure out the pin out of this and to connect to this and turn this guy into the USB HID something else. Okay, so I've been really far off from the main topic, start from the battery, and I thought that seller sent me a non-working battery, but it turns out that it's for Android and my one is incompatible for some reason. And it teach me a lot how to do something. I call it cell swap. Just get the old cell, throw it out, get a new one, replace it, connect to the circuit. And I also learn about the battery recalibration. I have a problem with this. Recalibration. Yes, get it right. Also, it's taught me a lot how to handle this really delicate device. And yeah, it's also taught me about this thing too, a field gauge IC. So I really learned a lot of things because of just replacing battery. And I hope you guys learned something new like this too. So thank you guys for watching this video. I hope you enjoy seeing my face. And see you again next time. Bye bye. See you again next time. Oh, before that, I have a project in background here. You cannot see it, but so this is my calculator. I'm gonna upgrade it, but I'm not gonna do it right now because yeah, a lot of things you're about to do, and I have some code to do with the let me grab this one. No. So from previous video, this is a sharp memory display, and I'm working on the library for STM8. Although this guy has just 1K of RAM, I'm gonna try to make it work anyway. And I actually started a project called Spy Mirror. The Spy Mirror is using the same technology with that memory display, but it's just a PNLC panel, really small. It's just square display, 96 by 96 pixel. I'm still about funding right now to get that display. So I want you to stick around so I can put a new project on YouTube, and also my website tilethacks.wordpress.com. So okay, I'm really gonna end this video right now. Thank you guys for watching this video. I hope you enjoyed this, and let's see you again next time on next video. Bye bye.